Hi and welcome back to Debugging Maths. So in this video I'll teach you how to find the cofactors specifically. So what do you do when you're asked in the exam or in a test to find the cofactor of a particular matrix? So that's what this video is going to be all about, the cofactors of a matrix. And let's get started. All the elements here, they all have what's called a minor and of course a cofactor. So now what we're going to do is we're going to label every single thing. So when you're asked to find the cofactor, all you need to do first of all is to label everything. This now will be called A11. So basically I can just name everything myself, so I'm going to go ahead to do that. This is A11, this is what? A12 and A13. So I've named this first part now A11, A12, A13. What about here? Here will be A21, A22, and A23. See? And then the last two, A31, A32, and last one, A33. So those are the coordinates. That's the first thing you need to do when they say find the cofactor of any matrix 2 by 2 or 3 by 3. First name them first. That's the first thing to do, right? So we just use this braces here, just use this line here first. That's the first thing to do so we can occupy all of them. So 2 is going to have its own cofactor, 3 is going to have its own cofactor, 4 is going to have its own cofactor, like that, all of them here. So we need to occupy all of them here. Very, very simple. And of course we're going to be using this as a guide. That's why this comes first. Very, very important. So now let's find the minor and the cofactor for the first element, A11, which is this 2 here. So to do that, start with, don't forget we're not doing determinants now. Determinants is done differently, so watch that video and master that one first. To find the minor, we need to know the sign first, like I always say. So we start like this, -1, and -1 what exactly? -1 all raised to power what? We're trying to find the sign first. You need to find the sign first before the minor. So -1 all raised to power what? 1 plus 1, because that's the first we're dealing with. 1 plus 1, that is 2, right? So -1 times -1, that is 1. So the sign here will be +1. So that's the first step, to know the sign first. Now what is the minor? So to find the minor, all we need to do is delete the row and the colon. The row and the colon associated with these 2 here. That's the first thing to do to find the minor. So to do that, delete the row and the colon associated with the 2 that we are working with. So what are you left with? 2, 4, 1, 3. So just write it here. 2, 4, 1, 3. Very simple. Now let's move on to the next one. To the second element, 3. What is the coordinates 1 and 2? So of course, to find the minor first, all we need to do is to find the sign first. So we start with -1. It's just a simple procedure to find the sign. Raised to power what? The coordinate 1 plus 2, which is 3 here. So now what is -1 all raised to power 3? That will be -1, right? So the sign that the minor will carry is -1, unlike this one that is +1. So -1. So we have -1 here. And what is the minor? Like I said, all we need to do is delete the row and the column associated with that element. Very simple. It's all the same procedure. So delete, we're dealing with these 3 now, so delete the row and its column. So what is left? 1403. So 1403. So to find the minor, the first thing we need to do is to find the sign. So what is the sign? We start with, by default, -1 raised to power, what is the coordinate? 1, 3. So 1 plus 3, that is 4. So what is -1 all raised to power 4? That will be +1, right? That will be +1, right? So meaning here will be +1. That's the sign first. What about the minor now? +1. So now let's find its minor. To find the minor, easy procedure. Delete the row and the colon associated with these 4. Very simple procedure, just like an iteration. And then what's left? 1, 2, 0, 1. So 1, 2, 0, 1. You want to take it step by step like that. So now we have the sign and we have the minor. We have the sign and we have the minor. Just for this first row, we need to do it for the second row and the third row with the same procedure. Now, whenever you combine the sign and the minor together, it's called the cofactor. So when you combine them together, you merge them together by multiplying them together, it becomes the cofactor. That's why it's called the cofactor. So this is a minor, and the sign merged with the minor becomes the cofactor. That's why it's called the cofactor method, or finding their individual cofactor. So now I've gotten the minor for every single element now. The minor and the sign, the minor and the sign, the minor and the sign. Now all I need to do now is just break them down. So let me show you how to break them down. All you need to do is multiply this by this, multiply the main diagonal here, 3 times 2. So 3 times 2 is 6. 3 times 2 is 6 minus, that's the procedure. So this times this minus 1 times 4, which is 4. So that's what you do. So let me take that again. Multiply this by this and subtract it from the multiplication of this other diagonal, 1 times 4. Very simple. So if you do that, you get 6 minus 4 is equal to 2. So it means this place here is 2. So the cofactor now is 2 because I'm multiplying the plus 1 with the final minor, which is 2. So if you multiply that, you get the cofactor. So the cofactor here is 1 times 2, which is 2. So you can see now I've converted the other weird looking minors into real numbers, scalar quantities, so which make more sense, and they are called the cofactor. So now let's do it for this one now. Very easy to convert this one. All you need to do is 1 times 1 is 1, right? So 1 times 1 is 1 minus 0 times 2, which is 0. So this is 1. So everything here is 1. So everything here is 1. And the moment I multiply 1 times the sign 1, it becomes the cofactor. So the answer here is 1. All you need to do now is replicate the process for the others. They are exactly the same. Multiply, replicate the process for the other ones, just like I did for 2, 1, and 1. Just do that for the others. So let me show you what that looks like. So I did mine, and everything looks like this: 2, 1, 1, minus 5, 6, minus 2, 5, minus 6, and 1. So this is the final answer, and this is the cofactor for everything, and that's how it looks like. Note that this is not the same thing as determinants. We did the determinant separate. So if I want to get the determinant, all I need to do is multiply. Just pick any row, but I recommend any row or any column, but I recommend this first row. So just take this first row and multiply it. So 2 times 2 and 3 plus, just multiply them and add them together. So 2 times 2 is 4, 3 times 1 is 3, 4 times 1 is 4, and then add everything together. That's how you get the determinants. But that's not what we are doing. This is strictly the cofactor. So once you get the cofactor, the question will just ask you, find the cofactor. So this is the cofactor which we have gotten. Let's try another question.